Hello and welcome to this video in which I walk through some examples of finding the greatest common factor. And I'm going to borrow this GeoGebra activity here. In it, Lee Fisher calls it the highest common factor. So it's the same idea. It's just different nomenclature. He's probably not from America, so they just have a different word for it. But it's the same idea. So what's great about this activity, we kind of have an easy example and we have a hard example. And so let's just walk through it and see what we can do. So let me see here, 27 and 9. If I want to find my greatest common factor, 27 and 9, I'll write the numbers up, and then I'm going to break them down into their primes. And so here I got 9 and 3, and I have 3 and 3. Now, we can probably look at 9 and 27 and figure it out, but I want to show you the process so that way when it gets more complicated, we have that process to rely on. Because we'll be able to do the same thing for 168 and 42 in a few minutes here. So now that I've broken down 9 and 27 into their factors, or prime factors, I will circle the ones they have in common. And so the greatest common factor is going to be the product of what they share, which is those two threes, which is 9. And so I'll go here, I'll type in 9, hit enter, I got it. Fantastic. Now, let's try the GCF of 168 and 168 and 42. All right, so here's where I want to maybe use some of my divisibility rules. I look at 168, I see those last two digits, and I see that it is divisible by 4. So I will go 4, and then that gives me 42. Cool. Actually, I could stop if I wanted to, but I'll keep going for the sake of keep going. Um, 42, 6 times 7, 3 times 2. Over here, 42, 6 times 7, and then we have 3 times 2. So sometimes, we unravel the whole thing just to end up finding out that we didn't have to unravel all of it, because what it shares in common is the 3, the 2, and the 7. The 3, the 2, the 7, and we multiply the 3, the 2, and the 7 together. So 3 times 2 times 7, we're at 42. When I did this, I could have stopped right there. Now, with 168, I broke it down differently. I could have taken out the 3, and then I might not have seen that 42. So, again, that's why it's always good to maybe go through the whole process just so that you catch everything. But anyways, type in 42. See what we get here. Awesome. All right, and now let's do a new problem. Let's see what happens. Oh, okay. Well, the first one, let's do a new one. All right, there we go. All right, so we have 21 and 18. So 21, 3 times 7, 18, 3 times 6. I'm seeing a 3, I'm seeing a 3. Boom. All right. Oh, now that other one, I didn't see that. Maybe I should have stopped. Let's see what we can do here. 1,320 and then 528. Okay, let me stretch it out a little bit here. It's going to get real. All right. Well, let's see here. I'm going to try to make this easy. So 10, 132. All right, very good. 10 is 2 times 5. 132, I can take out, let's see here. I'll take out a 2. I'll take it nice and easy here. So that will give me, let's see, so 66, which I can then break down again by another 2 to get 30. No, 33. One sec, sorry. All right, so 33, which is then 3 times 11. Let me double check my arithmetic on that. Okay, I feel all right about that. 528, that's going to be a little bit of work. Let's see, so all right, I'm doing the little trick for seeing if it's divisible by 3. That's the sum of the digits is 15, so I can take out a 3, and then that will give me 1, 1, 4, no, that won't. Oh well, I'm running out of time. I only have the free version here is for Screencastify only gives me 5 minutes, and I got 15 or 10 seconds left. So nonetheless, saw a good example of how all of this works.